Alright, hopefully you've taken your notes from Canvas and you see where the double angle formulas come from, and have those written down. So we're going to work some examples here. So our first example, we've got the sine of x equals 5 over 13, and they tell us that x is in quadrant 1. Alright, so that's going to be important that we know the quadrant the angle is in, and then whatever information they give us, that's what we're going to use to find any information that we need to know. So for example, for the sine of 2x, for the double angle for sine, I know that that equals 2 times the sine of x times the cosine of x. So I need to know what the sine of x is, and I need to know what the cosine of x is in order to evaluate this. Well, they've given me what the sine of x is. To find the cosine of x, just go to your handy dandy right triangle. So I'm going to drop a right triangle here. Label my theta. I know that the sine of x is 5 opposite over the hypotenuse. And if you didn't recognize that this is a common triple, go ahead and use your Pythagorean theorem to find that third side. And so that adjacent side is going to be 12. If the adjacent side is 12, we know that the cosine of x is adjacent over hypotenuse. And this is why it's important that I know what quadrant theta is in, because if it's in quadrant 1, all our values are positive. So if sine is positive, cosine is positive. So I've got everything I need in order to find the double angle for sine. So plugging this in, I've got 2 times the sine of x, which they told me was 5 over 13, times the cosine of x, which I found, and that's 12 over 13. And when I multiply straight across, numerator times numerator times numerator, I get 2 times 5 times 12, which is 120, and then 13 times 13, which is 169. So the double angle formula for sine tells me that my sine of 2x is 120 over 169. All right, let's find the double angle for cosine. And we know that that is cosine squared of x minus sine squared of x. Cosine is 12 over 13. I square that. Then I subtract sine squared. So I get 144 over 169 minus 25 over 169, which is 119 over 169. All right, so that's the double angle for cosine. And then the double angle for tangent, I don't want you to have to learn a formula, another formula. You've got enough formulas. There's lots of formulas in this chapter, so we're just going to know that tangent is sine over cosine. So the double angle for tangent is going to be double angle for sine, or the double angle for cosine, and I found the double angle for sine, which was 120 over 169. For cosine, it was 119 over 169. So I'm going to multiply by the reciprocal, see that those denominators cancel out, and I'm left with 120 over 119. Okay, so that's that one. I want to do one more of those to make sure you understand how important it is that they tell us what quadrant theta is in. Alright, so I am given that the cosecant of x is 4, which I know is the reciprocal for sine. So the sine of x is going to be 1 over 4. Alright, let's go ahead and talk about what quadrant we're in here. So I know that the sine and cosecant is positive. So that tells me it has to be quadrant 1 or quadrant 2. Well, they've also given me that tangent is negative, and we know that no function is negative in quadrant 1. So my only choice here is this theta has to be in quadrant 2. All right, why is that important? It's important because when I drop my triangle, if I need to drop a right triangle to find Remember, I'm using sine of x and cosine of x in order to find these double angles. So if I've got my theta here, and I know that sine is 1 over 4, opposite over hypotenuse, and I find that third side to find cosine of x, so my third side is going to be 4 squared, hypotenuse squared is going to equal that leg plus the other leg, right? So I've got 16 equals 1 plus x squared, or 15 equals x squared, so x is going to be the square root of 15. So when I found this third side to be the square root of 15, that's my adjacent side, so I know that the cosine of x is the adjacent over the hypotenuse, but since it's in quadrant 2, I know the cosine is negative in quadrant 2, so that is going to be negative square root of 15 over 4. Alright, so it's important that you find sine and cosine, but also pay attention to what quadrant theta's in, because that's going to determine whether your sines are positive or negative for those values. Alright, so let's find the double angle for sine. It's going to be 2 times the sine of x times the cosine of x. Alright, multiplying straight across, that gives me negative 2 square root 15 over 16, which you don't have to simplify any of these, but you certainly can factor out a 2 and get negative square root 15 over 8. Alright, for the double angle for cosine, that is cosine squared minus sine squared. Alright, so squaring the top, I've got a negative square root 15, so a negative becomes positive when you square it. When you square a radical, the radical goes away, so that's going to give me positive 15 over 4 squared is 16, minus 1/4 squared, 1 squared over 4 squared is 16. So when I do that, I get 14 over 16, or 7 over 8. So my sine is negative square root of 15 over 8. My cosine is 7 over 8. I'm going to use that to find my double angle for tangent. So I've got negative square root 15 over 8 divided by 7 over 8, which leaves me with negative square root 15 over 7. Okay, one more of these. And this is one like we've worked before when we are actually supposed to use our formulas and kind of work backwards. So hopefully you're recognizing this. I've got 2 times the sine of x times the cosine of x, which is the double angle for sine, right? And x in this case is what? Well, this is 2 times sine of x. Let me write it out. 2 times the sine of x times the cosine of x, which means x in this case, or my angle in this case, is 18. So this would be the sine of 2 times 18 degrees, or the sine of 36 degrees. So we can go backwards and simplify this to the sine of 36 degrees, recognizing that this is the double angle for sine.